Greg, thank you for coming on.
Thank you very much for having me today, Daniel.
You work in the directed energy field. Can you tell me what kind of the state of the world of directed energy right now? Where did this battlefield stand when it comes to directed energy?
Well, currently the congressional appropriations have been running, I think this year is around 1.1 billion, a little bit more than 1.1 billion in the U.S. We know that our adversaries are also working diligently on directed energy. Our NATO allies, Israel is putting a lot of funding into their directed energy program. Other countries, large and small, China and Russia, obviously been working in the directed energy realm for 50, 60 years since the advent of the laser over 60 years ago. So it's a well-funded area, but we're just now seeing insertion into battle space of directed energy platforms that are coming in multiple units.
And when we talk about directed energy, we're essentially talking about lasers, right?
It's lasers and it's high power microwave. I think those two. On the laser side, it's CW as well as the work we're doing in ultra short pulse lasers, and then there's also the work taking place with high power microwaves to try to jam the electronics on some of these sensor platforms.
And we don't hear too much about directed energy. Every once in a while we hear about a contract or something, but it doesn't come out on the news that much. Are we where we're supposed to be when it comes to using our directed energy tools?
I think we're getting there. I mean, it's taken the last 20 years for funding in the current CW solid state platforms that the U.S. has been working on. Other countries have been funding it fairly heavily as well as a portion of their government budgets, and they're trying to get things into protect their national security as well. But I think that the U.S., and we're now starting to see both high power microwave and CW systems put in as programs of record so that they're being purchased in multiple quantities, and we're seeing more funding put into next generation threat defeat, such as the ultra short pulse technology.
You mentioned CW. I'm not familiar with that acronym.
Okay, that's continuous wave. So that's a laser that you turn on and it stays on the entire time that you're trying to lock onto your target. Those systems are very high power, upwards of greater than 100 kilowatts. They lock on, and their primary mission is to burn through the target, whether that be the outside of a missile, whether that be the outside of a UAV. It's to lock on and burn through and destroy the aerodynamic stability of that threat. So they use that to try to take down the entire threat, but it does take a while to lock and target that.
And right now, it seems like directed energy is mostly being used to take down other threats, drones, missiles, that kind of thing?
Yes, it's being used primarily for defense of our national security. It's being used for defensive troops of maritime platforms, air platforms. It's to defeat incoming missiles, incoming drones, incoming any kind of munitions that may be launched that has a sensor on it or can be taken down with a beam of light or of microwaves.
And earlier we were talking before we started rolling here about Ukraine. What's going on in Ukraine within this realm, and what are we learning?
I think we're learning that it's not going to be just standoff and fire long-range missiles. It's going to be eyes on the ground and trying to see where the threats are moving. So it may be military hardware, it may be platforms, it may be aircraft, and using something like a drone or a UAV or an air-based platform to be in the sky and looking down to see where these targets are, whether it's with bolometers that are sensors that detect the heat given off, or whether it's visible or infrared sensors to try to see what is there and be able to target a counter launch to try to take that out. It's very important. So when you have something similar to what is being developed in the United States and other countries, which is laser beams and microwave, which can take down threats, if you want to keep the enemy from knowing where you're at, you need to blind the enemy. And I don't mean the personnel, I mean the UAV or the sensor that's on the aircraft that's flying over trying to sense where you're at to get your GPS coordinates. So you're really trying to find ways to counter the ISR that's on these platforms, destroy them so that they can't actually sense where you're at. And you're using the ISR yourself to target the GPS coordinates of where your next launch of munitions may be. So being able to use directed energy to either take down the aircraft or the drones such as using microwave or high power lasers, or be able to blind them with ultra short pulse lasers or CW lasers, is an important step to trying to defeat that part of the threat that's out there currently. And you're seeing a lot of use of drones, especially from the Ukrainian side. They've really mastered the use of off-the-shelf components to try to put technology in the sky so that their people can move around covertly and be able to get to the threats that are out there.
Directed energy, is that big, heavy technology, or is it something that someone in Ukraine they're really savvy with their technology, with their small technology, is it something they'd be able to plug and play?
That's what we're looking at. I mean, when we look at the directed energy platform, if you will, again, we're looking at using high power microwave. We're looking at using these continuous wave high power lasers, but also plug and play with something like our ultra short pulse technology that we're developing. And one of the reasons that we're really focused on that at Applied Energetics is because of the swap-C, the ability to reduce greatly the size, weight, and power of what's already out there in the field. So you can add this on as a portion of a layered defense and not impact the mobility of the platform that you're using.
What are you hearing from military leaders? What is it that they want on their ships, on their vehicles, on their aircraft?
Well, obviously they want something that is able to be used rapidly without having to have a PhD attached to it. You want it to be, to go with your command and control center and be able to intercept the threats at a distance that's applicable and eliminate that threat. So their primary worries are: do we have enough power to run this? Do we have enough cooling capability to keep pull the heat away from the laser itself? And do we have the software technology developed so that we can track the targets, look at their trajectory, and be able to intercept them with a beam of light or microwave or whatever it may be? So their big concerns are: how do we make this plug and play? How do we swap one system out, that may be using, munitions to try to take down these threats, and put in something that's using light? The beauty of it is light doesn't cost you anything other than part of your power budget. You're not having to have a supply chain to bring up more munitions to keep your folks working in the field. It's a matter of, do you have enough energy to power the technology, and then the light, the depth of the munitions is infinite, and the cost is very, very low. So it's a matter of making sure that you have the power to run the technology.
And in terms of development, where are you right now, and what's kind of the next frontier? Is there anything you're stuck on, something you're looking to advance rapidly?
No, I mean, everything that we're trying to do right now is being done in a very methodical way. I mean, we've had 20 years of experience and seeing what's been done with the continuous wave lasers and the microwave platforms. There's a lot of infrastructure there that's already been funded by the U.S. government in terms of power supplies, tracking, the ability to see in front of you and be able to measure, the distortions in the atmosphere. So what we have to do is piggyback on what's already there, and as rapidly as possible field a technology that delivers the amount of energy in the pulse and puts that energy on target in an effective way. So we have technology that's all the way from fundamental science that we've started to trying to bridge the gap from initial field testing to getting onto a program of record where we can be part of that layered defense.
All right, looks like there's a lot going on. Greg, thank you for joining us, and we'll see what comes up next.